So today we're going to look at solving trig equations, but for non-exact values. And what that means is it's not going to be a pretty number on the unit circle. So we're going to have to use the calculator. All right, so we are going to use Desmos, and super important, always make sure that you are in degree mode when you're finding these. Okay, so you should always get a degree answer. Now, when we use the calculator, so if you look over here at this note that I wrote, when we find that inverse value in the calculator, it's always going to give me my reference angle. And my reference angle is the angle measure that's in quadrant 1. So it's going to give me my theta value from quadrant 1. Now, based on the sign, right, that tells me what quadrant my trig function's in, my answer's in, we may have to use some of those reference angles equations to find the angle measure for the appropriate quadrant. So to refresh us on those, if my angle measure is in quadrant 2, that would be 180 degrees minus that reference angle I found in the calculator. Quadrant 3, 180 plus theta. And then quadrant 4 would be 360 minus theta. Okay. And another just quick refresher. Quadrant 1, I have positive x's, positive y's. Quadrant 2, negative x's, positive y's. Quadrant 3, negative and negative. Quadrant 4, positive and negative. Okay. So we're kind of going to do some of the same stuff, right? We're going to do the same algebra steps to get everything isolated and then figure out the quadrant. Then we're just going to do one more extra step, and that is solving for the angle, the reference angle, right, using the calculator, and then changing it to fit whatever quadrant I need it to fall in. So looking at the first example here, notice my bounds are a little bit different looking. We're going from 0 to 360, right? Because I need the degree measure, right? So instead of 2 pi, we have 360. So similar steps here to start. I'm going to move the cosines to the left and the numbers to the right. So subtract the 5 cosine x and subtract the 3. So I get 3 cosine x equaling 2. Divide the 3 over, and I get cosine of x equaling 2 over 3. So that's the first step. Okay, isolate the trig function. Second step, we're going to identify the quadrant I'm in. So cosine deals with my x values, and it is a positive number. So that's going to be quadrant 1, quadrant 4. So I'm going to have an answer from quadrant 1 and an answer from quadrant 4. Now we move on to step 3. So I'm going to finish this by taking the inverse, okay? Because I want to solve for that angle measure x. So I would get x equaling cosine inverse of 2/3. That's a positive number, right? And that's what I need. So I wrote this note here as well. Even if we get a negative, which we'll see in a few examples, I'm always going to plug a positive value into the calculator to get that theta measure for quadrant 1, okay? The negative just helps me to identify the quadrant I'm in, okay? So that's step 2. But this one's already positive, so I type in cosine inverse of 2/3 into my calculator, making sure it's in degree mode, and it gives me my reference angle of 48.1 degrees. So now I need to adjust that to get my 2 answers. Now, because quadrant 1 is where I need to be for one of my answers, that one's already done. That's found by doing the calculator stuff. So first answer I've got. I don't need to change that one. Now, second answer is in quadrant 4. So that means I need to do 360 minus the angle measure I found in the calculator. So 360 minus 48.1, and I get 311.9 degrees. Okay. So really we're only adding one new step. Using the calculator, I guess 2 steps. Using the calculator and then adjusting to the quadrant using one of those little equations we have. All right, second one, same thing. I'm going to move tangents to the left, numbers to the right. So subtract the 2 tangent x, subtract the 3, and I get 2 tangent x equals 4. Dividing by 2, I get tangent x equals 2. Okay, so there's my step 1. Step 2, figure out the quadrant we're in. Tangent is positive. Remember, tangent is y divided by x. So I either need a positive divided by a positive or a negative divided by a negative. So that would put me in quadrant 1 or quadrant 3. Okay. So now it's time for the calculator, right? Step 3. Take the inverse of positive 2, and I get 63.4 degrees. Again, I'm in quadrant 1 for one of my answers, so I don't need to change that one. So that's one of my answers found. Quadrant 3, I do 180 plus the angle I found in the calculator. So 180 plus 63.4, and I get 243.4 degrees. All right. Now, let's look at 2 examples where I'm dealing with a negative. So, step 1, get everything to the appropriate side. So I'm going to move the signs to the left, numbers to the right. So subtract the 2 sine x. Subtract the 6. So I get 3 sine x equals negative 1. Divide the 3. Sine of x equals negative 1/3. So again, identify the quadrants here. Negative y values would be in 3 and 4. Okay. Now, the only difference here is when I go to step 3, I want to find that reference angle. So I'm going to do the inverse of positive 1/3. Again, we always want to use positives to get that angle measure for quadrant 1. I do that, and I get a reference angle of 19.5 degrees. So that's the angle measure from my first quadrant. Now I just need to adjust it so that I get the angle measures that I need for quadrant 3 and quadrant 4. So quadrant 3, 180 plus 19.5, and I get 199.5 degrees. Quadrant 4, 360 minus 19.5 degrees, and I get 340.5. Okay. One more deal, looking at a negative again. Subtract the 6 tangent x to the left, subtract the 4 to the right, and I get 2 tangent x equaling negative 6, and then I divide by 2. So I get negative 3. So quadrants, negative tangents, that means I need one positive, one negative when I'm looking at x and y, right? So that'll happen in 2 and 4. Okay. Calculator. Tangent inverse of positive 3. and that gives me 71.6 degrees. So adjusting that to quadrant 2, I would do 180 minus 71.6, and I get 108.4. Adjusting to quadrant 4, 360 minus 71.6, and I get 288.4. All right, one more. Now we're going to look at another example of dealing with that double angle that I can't get rid of. So, moving everything, subtract the 9 sine 2x to the left, subtract the 6 to the right, I get negative 5 sine 2x equaling negative 1. And then I divide, and I get sine of 2x equaling positive 1/5. So this is where I look to see if I change it using the formula. It's not really going to help me at all. So I'm stuck with that sine 2x. So it is positive, right? So that's going to keep me in quadrant 1 and quadrant 2. So doing my inverse is going to look a tiny bit different. Okay, and when I take the inverse, I would have 2x equals sine inverse of 1/5. So I would have 2x equals 11.5. So because I have that 2x, we need to find our angle measures in quadrant 1 and quadrant 2, but for 2 rotations. So first rotation, quadrant 1, and quadrant 2. So quadrant 1, right? I have 2x equals 11.5, but I just need the original, or just the angle measure x. So I would divide by 2 and get an angle measure of 5.75. Quadrant 2, right, I would originally do 180 minus the 11.5, and that would give me 168.5. So I would have 2x equals 168.5. Dividing that by 2, I would get x equaling 84.25 degrees. Now let's look at the second rotation. So we're still looking at quadrant 1 and quadrant 2. So quadrant 1 rotation, for the second rotation, I would add 360 to the 11.5. And that would give me 2x equals 371.5. Dividing that by 2, I get 185.75. 360 plus the 168.5 would give me 2x equals 528 degrees. 528.5, sorry. Dividing that by 2, I would get 264.25 degrees. And those would be my 4 answers for that one.